Hi, everybody. I'm here to talk about code.org, both about where we came from, what we've already done, and what we're doing starting next week. When we started thinking about code.org, it really was about just an amazing opportunity, or you could see it as a problem. The problem, I would say, is that myself, my own life, and the other people I know around me who are in the tech industry all shared the same story. We we were among the lucky few to receive a computer and taught ourselves to program at a time where it was really uncool to be a computer programmer. I was basically the nerdiest kid in my school and was able to pursue a skill that changed my life in spite of the fact that it was so uncool. And so really the challenge for us was, how can we make computer programming be cool? In America, we all know about the issues with lagging behind in STEM, in science, technology, engineering, and math. But believe it or not, in most of the country, the vast majority of the country does not even include computer science in STEM. And so while we've tried and failed to really catch up in STEM, we're even farther behind in computer science. If you look at all the different areas that people study, that last tiny little column on the far right is computer science. It's behind not just history, English, all other sciences and math, but even behind art and music. It's only taught in about 5% of schools. And only 17% of those students are girls, which is way down from where it was just 20 years ago. Furthermore, computer science overall has declined in the last 10 years. It peaked around 2003, 2004, and it's significantly lower now, both at the high school level and at the college level. And this is not just a problem for development, it's a problem for our economy. There's only about 2% of Americans study computer science, but 60% of the jobs in STEM are actually computer science jobs. So when we talk about STEM-related jobs, we really mean computer science jobs, yet our schools are not actually teaching the one part of STEM that they should be teaching. This is resulting in a gap of about 1 million jobs that need people to fill them, but we don't have the graduates in this country to fill those jobs. It's an enormous monetary economic opportunity worth perhaps $500 billion. So, and it's not, by the way, just about my industry. I'm from the software industry, from the tech industry. Most of these jobs are not in the tech industry. And the tech industry may have a challenge hiring computer programmers, but the other industries have a far greater challenge. It's not that hard for Facebook or Google to hire computer engineers. It's much, much harder for the hospitals, for the manufacturing companies, for every other company out there that also needs engineers and can't hire them. So it's increasingly clear that, if education is to prepare children for life, basically, and if the point of public education is to make opportunity equal across, people of different backgrounds, we should be preparing kids for life in the 21st century. And in the 21st century, some knowledge of computer programming is necessary no matter what you want to do when you grow up. 100 years ago, it was helpful for every child to learn how to dissect a frog. Today, I think it's more useful for every child to know how to dissect an app or to have a sense of how the internet works. So what we did with code.org at first was just, we were trying to figure out how to make computer programming cool. So we created a short video that featured Bill Gates, Mark Zuckerberg, Jack Dorsey talking about computer programming, and also celebrities like will.i.am and Chris Bosh, both of whom have actually learned to code. And this video had enormous spread. Actually, how many people here saw the code.org video? Okay, a decent number of people. Now, you might think that was just a video, but let me show you the immediate impact from that video. Over 20 million people saw the video. It became #1 on YouTube. More than 3 million students began learning computer programming online directly as a result of that video, either on our website or on the various websites that we linked to. This number is now close to 1 million people have signed a petition, which is 4 times bigger than the single largest White House petition, which is an amazing level of public support. And 13,000 schools came to us and said, we want to support computer science. We want to add it to our school. What can we do? Can you help us? Likewise, 25,000 engineers volunteered, signed up on our site, offering to help teach it. So what we've been doing since then, this was back in March, we've been working on what can we do to harness that interest, and what do we do next. Well, I forgot to mention, the high schools that showed the video in their school literally saw their computer science class enrollment triple for the next semester. So that's an amazing response rate from just one video. There's a couple of interesting quotes here we picked out from posts that people put on our Facebook page. The one that I've highlighted is my favorite one, where this is somebody who literally said this one video inspired them for what they want to do with the rest of their life. So it's amazing how much you can accomplish with just a video. So in terms of what's next, we decided to do, for the next stage, to divide our efforts into 3 areas, which we designate by the words educate, advocate, and celebrate. As far as educate, we're trying to build curriculum where none exists today. There's a fairly well-defined curriculum for high school computer science, but you can start teaching computer science to first graders. In fact, a lot of studies are showing that, in fact, it's easier to learn the basics of computer programming than it is to learn how to read and write English. Because English is actually a very illogical language, whereas computer programming is very logical and is much easier for kids to grasp. So we've built our own curriculum for that K through 6 level, where no curriculum really existed before. And we built it in a way that's taking advantage of all the modern tools. It's web-based, but you can access it on a phone or on an iPad. And what's really cool is that when a student is going through it, trying from screen to screen, we're getting stats on how far they're going and where they're running into trouble. So we can see exactly that, if, at level 13, kids start dropping off because they couldn't complete it. We can see exactly which are the points that people have difficulty with, so we can go in and fix it and make it easier to understand, or add a video to help them solve the problem if they don't know how to get through it. This curriculum is being released. Actually, I think it's, as of today, is available on code.org, but it's being promoted heavily starting on Monday this coming week as part of a bigger effort that I'm going to tell you about. The other part of our efforts has been advocacy. We're now launching a on-the-ground advocacy effort all across the country. There are 37 states that don't even recognize computer science as counting towards high school graduation. So in California, if your child takes AP computer science, this is a college-level science class, the universities count it as a science class towards their college degree, but your child's high school won't recognize it towards their high school diploma. So it's equivalent to if they took, pottery. Literally, we're in an argument with Seattle school districts that are saying, well, we don't want to offer computer science because we would have to cut ceramics, which is, these are the 2 electives that they're comparing against each other because they don't count towards graduation. On the plus side, we've already successfully passed laws in 3 states just in the last 6 months since our video launched. And we're going to get these laws changed in the other 37 states that are left to go. It's just a matter of pointing out to people that the laws and the education standards have not kept up with the reality of the past 20, 30 years. So one thing I will point out, though, is that when in the states that do recognize computer science, obviously enrollment goes up because it counts towards graduation. But more importantly, enrollment in other maths and sciences also are higher in those states. Studying computer programming makes you more excited to study other things because it makes math more relevant to you. You can make a cooler game if you know how physics works. And so computer programming doesn't compete with other maths and sciences. It makes the other maths and sciences become more tangible and more exciting and more real. And then the last part I mentioned is celebrate. And what we're about to kick off on Monday is the culmination of many months of work. We've put together a massive, not just nationwide, but worldwide promotion timed with Computer Science Education Week. Next week is Computer Science Education Week, which apparently has been celebrated for 10 years, although no one's ever heard of it before. We decided that this year we will make everybody hear about it. And so we've pulled together an enormous promotion. I can't, unfortunately, disclose some of the most exciting parts that came together in the last couple of weeks, but we have thousands of schools, literally actually 33 1,000 schools across 166 classrooms have committed to have all their students engage in 1 hour of computer science. So rather than trying to convince a student to study it for a whole year or for their lifetime or whatever, just 1 hour's worth is enough to get a feeling for it. The premise, the way I think of it is, if you were going to go to, let's say if you were going on a vacation to France, you don't have to become fluent in French, but it would be nice if you were going on a trip to France to spend maybe 1 hour learning a few French words so that you could interact with the local people. Similarly, if you're going to live in a world surrounded by technology, you don't have to be a software engineer, but it would help to spend maybe 1 hour learning the very basics of how computers work, just because that's the world you're going to be living in. So the Hour of Code is, as I mentioned, is next week. We now have about 5 million students already pre-registered to participate in it. The curriculum that we're releasing features video lectures by Mark Zuckerberg and Bill Gates teaching you how to code. And it features artwork from Angry Birds and Plants vs. Zombies. So the two most popular games of all time are what we're using to teach people how to code. I was going to show a demo, but I think unfortunately they told me I wouldn't be able to get it on this screen. But if you go to code.org, it's live now, and it starts at the simplest possible level. In fact, you might be turned off because it's so simple. You might think this is childish, I'm not learning anything. It is truly, it starts at a simple enough level that a second grader or first grader can do it. But I will say, if you took Computer Science 101 at Stanford, that also begins at the same level. And it's because in a country where computer science hasn't been taught in high schools, even the best university in the world has to begin with the ABCs. And so this program begins with the ABCs, but if you proceed through it, the levels get harder and harder. And we have a 1 hour tutorial as well as a 20-hour follow-on. And hopefully some of the kids that try it will get addicted and not be able to quit. And we really have designed the whole thing with game mechanics, like you proceed through levels and get rewarded, feeling of accomplishment for getting to the next level. So that's a map of all the places that have signed up to participate in the Hour of Code. Next week, you're going to see an enormous outpouring of support from celebrities, politicians, world leaders, and local governments all supporting it. So it's an enormous kickoff. In my opinion, it's just the kickoff. It's just the beginning. For us, what's to come next is to actually get schools to add computer science into their classrooms. So this is just a one-week promotion to give people, we think of it as the gateway drug. 1 hour of code will hopefully be enough to get students, teachers, parents, and schools to feel like they have to embrace this. So I want to close by telling the story of Makinde Adeagbo, my friend Makinde, who actually appears in several of our videos, is a man who was born in Africa. His parents immigrated to America when he was about 3 years old, and they set up in Kentucky. So he grew up in Kentucky. He's an African, and he studied computer science. And because he studied computer science, he was able to get a job at Facebook when it was really small. And after Facebook, he worked at Apple and then at Dropbox. And because of because of those jobs, he's now financially set for the rest of his life. And he's turned to doing nonprofit work. I recently asked him what he was doing, and he said, he's working for Bridge International Academies, which is a company in Kenya that builds schools. I was like, that sounds neat. You retired and you moved to Africa and you're doing Peace Corps type work in Africa. And he said, no, that's not what I'm doing. I'm a computer scientist. So the question is, how does a computer scientist help build schools in Africa? And so I have a video of him describing his work.
After I left Facebook last year, I was sort of searching for the next opportunity and wanted to maybe give back a little bit or do something different, right? So I, through a job board and talking to some people, found an opportunity to go work in Nairobi. So the company was Bridge International Academies. What they do is they build primary schools in slums, right now in Nairobi, but looking to expand to Kenya and more of East Africa after that. And you probably think, why do you need a software engineer there? So There are a number of things. So one is, where do you build the school? So you know there's a slum, and can that slum support the school? So you answer that question by saying, okay, well, how many households are there? How many children are in those households? Well, it turns out without great census data, that's not an easy question to answer. So what they actually do is they take satellite imagery and use software to count the rooftops. Even something as simple as, hey, we want to buy this plot of land, and we have certain parameters that make it a good plot. How do we find out if this plot of land fits? You can also just write software for a simple cell phone and walk around the perimeter of the plot and have the cell phone pick up GPS data as you're walking, right? So you can use technology to solve these problems that you wouldn't think it applies to in sort of novel and simple ways.
Anyway, I want to show that video to give you a sense that computer science is not just about the tech industry, and it's not just about people trying to build the next app. It's something that transforms and pervades every aspect of our lives and really empowers so much of the future that's to come. So next week, you will probably start hearing about the Hour of Code. If you haven't already today, you're going to hear about it because it's going to be taking the education world by storm. I hope you participate in whatever way you can, and hopefully it's the beginning to, for us, this is a 10-year effort we're hoping to get into 100 schools, to bring computer science classes to 100 schools next year, to 1,000 schools the year after, and to every school in America by the end of the decade. Thanks very much.